Can we really predict when a volcano will erupt? From ancient myths to modern science, join us as we explore the fascinating history of volcanic prediction. Throughout human history, the awesome power of volcanoes has both terrified and captivated us. These geological giants have shaped our planet, influenced our climate, and even altered the course of civilizations. But for all their might, volcanoes have long remained enigmatic, their fiery tempers seemingly impossible to forecast. The quest to predict volcanic eruptions is as old as humanity itself. Ancient cultures, lacking our modern scientific understanding, turned to myths, legends, and religious beliefs to explain and anticipate these cataclysmic events. In Hawaii, the goddess Pele was said to reside within the volcanoes, her moods dictating their activity. The Romans believed that Vulcan, the god of fire, forged weapons for the gods in his subterranean workshop, causing tremors and eruptions when his work grew particularly intense. As civilizations advanced, so too did our attempts to understand and predict volcanic behavior. In 79 AD, Pliny the Elder's fatal curiosity during the eruption of Mount Vesuvius marked one of the earliest recorded scientific observations of volcanic activity. His nephew, Pliny the Younger, provided detailed accounts of the event, laying the groundwork for future volcanologists. Fast forward to the 18th and 19th centuries, and we see the birth of modern volcanology. Pioneers like Sir William Hamilton and Charles Lyell began to study volcanoes systematically, documenting their observations and developing theories about volcanic processes. These early scientists relied heavily on visual cues and historical patterns, noting changes in the landscape, unusual animal behavior, and even the taste of well water as potential harbingers of eruptions. The 20th century brought with it a revolution in volcanic monitoring. Seismographs, first developed to detect earthquakes, proved invaluable in tracking the underground rumblings that often precede eruptions. Tiltmeters and GPS systems allowed scientists to measure minute changes in a volcano's shape, indicating the movement of magma beneath the surface. Gas emissions, particularly sulfur dioxide, became key indicators of increasing volcanic activity. But even with these advancements, predicting eruptions remained a complex challenge. Volcanoes, it turns out, are as unique as fingerprints. Each has its own personality, its own set of behaviors, that may or may not signal an impending eruption. What works for one volcano might be completely irrelevant for another. Take, for example, the contrasting cases of Mount St. Helens in the United States and Mount Unzen in Japan. The 1980 eruption of Mount St. Helens was preceded by months of seismic activity and visible deformation, allowing scientists to issue warnings that saved thousands of lives. In contrast, the 1991 eruption of Mount Unzen caught many off guard, despite ongoing monitoring efforts. These unpredictable outcomes have driven volcanologists to develop more sophisticated prediction methods. Today, we employ a multidisciplinary approach, combining data from various sources to create a more comprehensive picture of a volcano's state. Satellite imagery allows us to track changes in heat signatures and ground deformation over vast areas. Drones equipped with thermal cameras and gas sensors can safely gather data from active volcanic sites. Even social media and crowdsourcing have become valuable tools, with local populations often providing real-time observations that complement scientific data. Artificial intelligence and machine learning are also playing an increasingly important role in volcanic prediction. By analyzing vast amounts of data from past eruptions, these systems can identify patterns and correlations that might escape human observers. Some AI models have shown promising results in forecasting eruptions, hours, or even days in advance. Yet for all our technological prowess, nature still holds many secrets. The 2018 eruption of Kilauea in Hawaii serves as a humbling reminder of the challenges we face, despite being one of the most closely monitored volcanoes in the world. The scale and location of the eruption caught many experts by surprise. So, can we really predict when a volcano will erupt? The answer is both yes and no. We've come a long way from the days of mythological explanations, and our ability to forecast volcanic activity has improved dramatically. In many cases, we can now provide valuable warnings that save lives and property. But the Earth is a complex system, and volcanoes remain one of its most unpredictable features. The future of volcanic prediction looks promising, however. Advances in technology continue to provide us with new tools and insights. The development of fiber optic cables that can detect minute ground movements over large areas could revolutionize our monitoring capabilities. Improvements in satellite technology may soon allow us to track volcanic gases and heat signatures with unprecedented precision. Moreover, our understanding of the processes that drive volcanic eruptions continues to grow. Recent research into the role of crystal formation in magma, chambers, and the influence of tectonic stress on volcanic systems is shedding new light on the mechanisms behind eruptions. As we look to the future, it's clear that predicting volcanic eruptions will remain a critical challenge for scientists around the world. With over 1,500 potentially active volcanoes on Earth, and millions of people living in their shadows, the stakes couldn't be higher. Each eruption we successfully forecast, each life saved, is a testament to human ingenuity and perseverance in the face of nature's most awesome forces. But perhaps the most valuable lesson we've learned in our quest to predict eruptions is one of humility. Volcanoes remind us of the raw power of our planet and the limits of our understanding. They challenge us to keep pushing the boundaries of science, to remain vigilant, and to respect the delicate balance between human civilization and the natural world. As we continue to unravel the mysteries of these geological giants, one thing is certain: the story of volcanic prediction is far from over. It's a tale of human curiosity, scientific advancement, and our enduring fascination with the forces that shape our world. So the next time you hear about a rumbling volcano or see footage of an eruption, remember the centuries of effort that have gone into understanding these phenomena, and the ongoing work to keep us safe from their fury. Can we predict when a volcano will erupt? Perhaps not with absolute certainty. But with each passing day, each new discovery, we're getting closer to cracking the code of these geological time bombs. And in doing so, we're not just saving lives, we're deepening our connection to the very planet we call home.